Today, we are going to solve together the kendaku puzzle. Kendaku was started in Japan and it was developed by Tetsuya Miyamoto in the year 2003. Later in 2007, it was distributed throughout the world and it got spreaded wide. So the puzzle is shown here for a 7 cross 7 grid. Whenever you have an n cross n square grid, you can enter numbers from 1 through n, like 1, 2, 3, 4 till n, such that each column or each row should contain exactly one occurrence of these numbers. There should not be any repetitions. Moreover, there are some arithmetic provided in the thick square box. As you could see, some multiplication, division, subtraction, addition. That means that the number present in those boxes should satisfy the arithmetic provided. The kendaku puzzles tests your critical thinking and your arithmetic skills along with your patience. So I feel that solving together makes us move faster. So I'm going to give some hint. You can also think meanwhile by pausing the video whenever required. Let's get started. So this is the kendaku that we are going to solve today. This is a 7 cross 7 square grid. So which means you can input numbers from 1 through 7. So we will start with the obvious square grid, that is 1 cross 1 cells. There is only one 1 cross 1 cell with an arithmetic 7. So just fill up 7 over there. There are no more 1 cross 1, so we cannot go further with this. Then comes the extreme cases. 13 is sum of 7 and 6. And those two are the largest numbers, so we have to input 7 and 6. In this rectangle, remember you cannot input 6 and 7 because 7 should occur only once in the second column. Alright, next 21, how can it be formed? The prime factorization of 21 is 3 times 7. So each 3 and 7 should be the entries of those cells of the rectangle. So you can either have 7, 3 or 3, 7. But again, you have 196 here, which is a multiple of 7. So let's find its prime factorization. 196 equals 2 square times 7 square. It's like 14 square and I split it 14 as 2 into 7. So the number 7 should occur twice and it can be like 2 times 2 times 7 times 7 or 1 times 4 times 7 times 7. There cannot be any other 4 split of 196. So 7 should occur twice irrespective of the configuration. So I must place them in separate columns. So I am placing them in consecutive columns as shown. Now you have the two cells in the same column, so we avoid equal numbers. Therefore we input 1 and 4. But wait, I don't know in which order they occur, so I am going to regard them as possible candidates for these cells. So I have 1, 4 and 1, 4. By the way, this column is already filled up with 7. I cannot repeat, so you should avoid 7 here. And for 21 we need 7, right? So therefore I include 7 here and 3 here. Again, 21 is formed by 7 and 3. The remaining cell is just 1 because you cannot have any other prime. So 1 should be filled here. Now again you have candidates. Either it is 3, 7 and here also 3, 7. Alright, addition gives you 3. When does that happen? When the numbers are 1 and 2. Here you have only 2 cells. So the possibility is 1 and 2. Let's write out that candidate. 1, 2 here, 1, 2 here, even 1, 2 here. Good. And notice 15 here is formed of 3 cells. What 3 numbers when added gives you 15? The possibilities will be many when you consider 7. But remember, 7 cannot occupy any of those 3 squares, hence I avoid them. So 15 is then the sum of maximum possible numbers 6, 5, 4. Alright. But I don't know in which order I'm going to write those numbers in the 15. So first of all, I can either think of filling a 6 here because I cannot fill 6 in this cell. But all these cells already have candidates that do not include 6. So all the cells except this one avoid 6, hence that one must be 6. Right, now we have 5 and 4. But before that, all the numbers except 5 are filled. in this column. So fill up 5 here and 5 minus 2, 3 here. You cannot have 5 plus 2 because 7 is already filled up. Okay, this implies the possible candidates for this one, division equal to 2, are 1, 2, 2, 4, 3, 6. So we must have 4 and 5 here. That means eliminating 4 and 5, we are just left with 3 or 6 for the difference of 3 over here and nothing else. You cannot have 2, 5 because 5 is already filled up. You can't also have 1, 4 because 4 is also filled up. 3, 6 is the only possibility. Of course, 4, 7 isn't possible as 7 is filled up. So let's write out the candidates 3, 6 here. Now, the only possible division that results in 2 is 1 and 2. So the possible candidates are 1 and 2 here. Alright. Now in the very first row, I need two numbers that divide to give you 2. They are the same 1, 2, 2, 4, 3, 6. 1 and 3 are already used in the first row. So we eliminate the other two to get 2 and 4 in some order. But when 2 and 4 occurs here, we are left with 5 and 6. So 6 must occur here, 5 must occur here because of the occurrence of 6 in the second column already. And now when you think of 6 in the last but one row, you will observe that 6 can't occur here because of the element in the first row, first column. And 6 can't occur here, otherwise it should have 3 here, which is a contradiction. So 6 can't occur here, neither here, neither here. So it means it must occur in one of these two squares and also not here. That means 6 holds this position. So holding a 6 there will give us possible candidates of 1 and 4 in the two other cells or 3 and 2. The reason why I don't write 2 and 3 is because 3 is inevitably going to occur in the third column. So you cannot have it in the last row. Let's think about the possibility of 5 in the third column. 5 can't occur here, not here, not here, not here. So it must occur in one of these two. So the other two numbers should add up to 5. So the possibilities are 1, 4, it can't be 4, 1 because 1 has already occurred in the first row. It can be 3 and 2, but 3 is forced to not occur in this row because let us prove that the number 6 is going to occur in these two cells. This is because for 17 you either have the sum to be 7 plus 6 plus 4, or you can have 6 plus 6 plus 5. And 7 cannot occur here, so it must occupy this place if the first case is going to happen. That means 6 should be there in the two cells highlighted, and that makes this element to be 3. It cannot be 6. So we erase the candidates and write out 3 and the below one as 6. Alright, now having a 3 in this row and 3 in these two cells will prohibit 3 in this entire 10 plus configuration, in this 10 plus arithmetic. So therefore 1 plus 4 should be the result of 5, and hence this cell is occupied by 1 because these two cannot hold 1. If 1 occurs here, I must have 3 in this cell, and I know that 4 must occur in one of these two. That means you cannot have a 4 here. So I'm going to fill it up with 2. And if this is 2, then one of these two will be eliminated. So it's like 1 and 2. And due to that, we get this last square to be 4. And 4 plus 3, 7 cannot occur. So 4 minus 3, 1 must occur. We already have 1. So we eliminate 1 and write out 4. And this must be 1. Now the last but one row has all the elements except 5. So this is 5. And this can't be 6. So this must be 4. Due to the occurrence of 4, you cannot have 4. So this is 5 and this is 4. So we are slowly getting up to the solution, as you could see. Now I just wrote this as a possibility. Now you cannot have 1 here, so this is 2 and this is 1. Alright. For the 15, we have the remaining as 5 and 4. So we don't know which one will occur for sure. Over here the remaining numbers are 2 and 3. So 2 will be here, 3 will be here as it constrains. And notice I already have the number 4 occurred in this column. So if 4 is going to occur here, it will hold this place. So this will be 6 and this will be 7. That is one possibility. Or you can have a 6 and 6 and a 5. So this is still not yet decided. So now we observe that the number 3 cannot occur here nor here. So it will hold this position and that will block the 3 here, leading to 7, and this will be 3. After finding this, we can fill up the candidates for this cell. So it is either 1 or 2. But 1 is already filled up here, so we avoid 1. So this is 2 and this is 1 and this is 2. So to make the sum to 9, I must have a 4, and therefore 4 must hold this place and 5 will hold this place. Now I have only one cell remaining, so this will be 6. And since this is 6, the only possibility is 6, 6, 5. And 4 occurred here, so we block this 4 and we write 2 and 4 here. Now these two are just determined obviously. Maybe you can do that as a homework and put out in the comments. So this is a way to solve the kendaku. So we just list out the possible candidates and we eliminate each one by one as far as we can. So at some point of time, you have to use that patience to completely eliminate a particular number in a row or column and go ahead with your candidates. It's not only possible by candidates. You have to use your own interpretation of them. So we solve a lot of such problems in SuMON, and students come up with different strategies to attack that. And we also have some mathematical intriguing games. So you may join us if you like these kind of problems. We will keep you posted with lot of such math puzzles. Thank you for watching. Bye.